Hello everyone, welcome to Engineering Bookshops. For this video, we're going to solve problems on our Engineering Mechanics Statics textbook. So here, about Chapter 2 review problem. So I'm going to solve problem 2.94 wherein we need to find our magnitude P with given moment of force P about axis AB equals to 600 Newton meter. So I'm going to show you the step-by-step process on how to solve this problem. So just keep on watching us and let's start. Problems 2.94. So we have to find the magnitude P. So we have given moment of force of our P about axis AB equals 600 Newton meter. So how are we going to find our magnitude P based on this problem? So the first step that we must do is to get all the coordinates of our point. So for our point O, so this one is our origin. So therefore this will be 0, 0, 0 coordinates. For our A, we have 0 for our x-axis. So from origin to x-axis, as you can see, it has no distance, so it will be 0. For our y-axis, as you can see from the origin to this one is 8. And for our z-axis from the origin, so as you can see, it doesn't go up or down, so therefore it will be 0. And then for our B, point B, so we have 8 cosine, negative 8 cosine 30. Why it is negative? Because it's going towards the negative x-axis. And it is 8 cosine 30 since we apply here cosine theta equals adjacent side over hypotenuse. So adjacent side is this one, which our hypotenuse is 8. And cosine theta is cosine 30. And we have the value for our 8. For our y-axis, which is 8, and for our z-axis, this one, it is opposite side equals hypotenuse sine theta, which is 8 sine 30. Positive since it goes up from here to here. And then for our point C, coordinate C, we have 8 cosine 20, so same adjacent, hypotenuse cosine theta 8 cosine 20, and it is positive since it is on the positive x-axis. We have 0 for y because as you can see it doesn't go towards to our y-axis, and we have positive 8 sine 20 for our z coordinates. So this is the first step. And then for our next step is to use this formula since we have our moment axis AB given and we need to find our magnitude P. So where this M is our moment axis. This M will be our R times F, where R is the position from any point on axis to any point on the line of action F. And this one is our unit vector of the moment axis. So what will be the following coordinates that we are going to apply for us to solve this problem? So for this one, applying this formula, we have MAB. So that will be our moment axis AB. And then this one equals RAO. So this one, it can change. You can choose AC or AO or BO or BC because as you can see from the definition, it is position from any point on axis. So position from any point. So it can be A or B. And then any point in line of action, it can be O and C. But the best thing that you can do is to analyze our given coordinates. So as you can see, if I will going to choose, for example, AC, so it will give us 3 coordinates. If I choose AO, it will only give us 1 coordinates. If I choose BO, it will also give us 3 coordinates. If I choose BC, it will also give us 3 coordinates. So the technique here is to choose the least number of coordinates. So based on your observation also, you can check based on the problem, based on the given figure. So as you can see, point O and A is flat or level on each other. So therefore, it will give us the least number of coordinates. So therefore, I am going to choose R A from our axis, and then O from the point on our line of action. Then multiply by our magnitude P times our unit vector of our moment axis. So what is our moment axis? AB. So therefore, this will be unit vector AB. So this is our second step. And now let's apply this formula using scalar triple product. So this will happen. So for our RAO, it will be O minus A from our coordinate. So 0 minus 0 is 0. 0 minus 8 is negative 8. 0 minus 0 is 0. And then for our P, so as you can see here, for our X axis, we have P cosine 20. And then 0 for our Y. And then here, we have upward force will be P sine 20. And then for our unit vector AB, so applying this formula, so we have, since it is AB, it will be B minus A. So B minus A, so negative 8 cosine 30I. And then we have 8 minus 8 is 0. And then 8 sine 30 minus 0 is positive 8 sine 30. And then over is square root of 8 cosine 30 squared plus 8 sine 30 squared is equal to 0. So let's check if it is equal to 8. So let's check if it is equal to 8. So 8 cosine 30 squared plus 8 sine 30 squared so it would give us the value of 8. So therefore, our I will be negative cosine 30 since we are just going to cancel this 8. And then for our K, we have sine 30. And now, let's proceed to find our magnitude P. So again, we have given moment force P about axis AB equals to 600 Newton meter. So it will give us this. So our moment AB equals to 600 equals, so this will be 0. So we are going to start at negative 8. So negative quantity negative 8 multiplied by P cosine 20 multiplied by sine 30 minus P sine 20 times negative cosine 30. So it will give us the value of our magnitude P equals to 97.91 Newton. So let's check. So 600 equals negative 8 P cosine 20 sine 30. So P cosine 20 sine 30 minus P sine 20 negative cosine 30. So should solve. So here, our value is 97.91 Newton. So this is for our problem 2.94.